So as you can all see, we've been assembling this drone. We got our flight controller in, which is our F405 Mini. So that's what's going to go in this. We're going to have this hood sitting over the top, obviously, and we're going to have power from the this is where the mount will go. I'll make a small TPU mount for it, mitigate some vibration. Obviously this is an EDF drone, 70mm. We're going to be finishing up the wiring on these ESCs to the power distribution board. We already have power to the Arduino board, which will run the light rails that I have inside, so this whole thing is going to glow. It's going to look beautiful. And these are solid copper wires, like I mentioned before, which I switched out the copper clad aluminum because it just wasn't transferring heat as well. There was too much resistance, so we get too hot. Because you got to remember, when we're running EDF engines, when you run EDF engines, you have to have something that can handle that current. It's going to produce a lot of heat. This is done on a 6S system, and I don't plan on doing it on a 4S because the amps are too high. This can handle 500, which is why I use this, piggyback it onto the flight controller and bypass the power distribution board on the actual flight controller itself, and I power it with the 12-volt out that I have up here, so the board actually gets power once you plug the battery up. And then that will power the lights for the Arduino. This will power the motors, control the ESCs with all the motor inputs and outputs. Telemetry will go from here to the SpeedyBee's UART4. That'll be set up as ESC telemetry and iNav, and that will give us the opportunity to keep an eye on the battery voltage, and I can set up the warnings on the TX16S transmitter, which I'm using for this, to let me know what my battery is and where it's at, so we can actually get some real-time data as opposed to just timing the flight like I did last time. That will give us more data as far as how much power consumption, how fast. It'll also keep the battery safe by keeping those cells at above critical as far as the voltage is concerned. So we're going to get the rest of this wired up, and then I will be back here in just a moment, and we will continue the assembly of this drone. Again, the Shrike V10 Reborn in clear PETG 70mm EDF drone. Can't wait to get her back in the air. Okay, so we saw the ESCs go in, and I was waiting for more capacitors because these capacitors here are 50 volt, 1000 UF, and they are PX. The YXF ones are a little bit better of an electrolytic capacitor. They can help improve in ripple filtering, lower ESR, and higher ripple current rating. Cleaner DC power, in other words, and less voltage sag. So these are going to get swapped out with these new big bad boys that just came in. And these are the YXF and not the PXF. So it's a little bit bigger capacitor compared to the other one, but it is going to give me a lot more protection, like I said, with the ESR, higher ripple current rating. It handles spikes a lot better than it did before, and since we're running EDFs, we want to make sure that we smooth out that power. It can reduces the stress on the MOSFETs, which is also good for the ESC's health. So that's why these are going to replace these. And I got a pack of those. It was only like $8, you know. You get a pack of let's see, I got 1, 2, 3, 4, 5, 6, 7, 8 of them. I got 8 of them. $8, $9 actually, and it's not a bad deal. And it's going to double the protection for this ESC. And realistically, in a standard drone application, you wouldn't really need to do this. And even in the EDF application, I didn't need to do this, but we did have problems with heat. We wanted to make sure that we would control that heat better. And these, swapping out these, now they're the same voltage, 50 volts, 1000 microfarad. It's just a YXF and not a PXF, or not a PX. So the YXF is going to give me a lot better performance out of the ESCs. So that's where we're going with that one.
Alright, so let's go ahead and wrap this up. We saw the ESC installation, and the motors are on the way that are going in here. Those are 2100 kV 6S 70mm EDFs. You saw this probably on the first V10 maiden flight. And the differences that we've done today is, one, we got some real good welding wire, which is actually my connection point for the 6S LiPo that I'm using, the 6000 milliamp 100C discharge rate. The SpeedyBee is set up. I'm printing a TPU mount that goes under here just to mitigate some vibration. We have all of the motor leads coming from the power distribution board and a telemetry wire for ESC telemetry going to the SpeedyBee, and that'll be on UART4. And of course we have our lights going for the Arduino. So everything's working like it's supposed to, and right now what we're going to do is get the TPU mount installed, make sure that this is sitting in the perfect position before it's CA glued into place. We have a top here so we can take it off the mount. I've got to tuck some wires and do a little bit of zip tying, things like that. A little bit of maintenance on the cleanup, and then what we're going to do is, once the motors get here, we're going to install those and we're going to do a flight. In the next video, what we're going to do is go over PID loops, and then we are going to go over a maiden flight. We'll do it right here in the garage. This flies indoors very well, and outdoors even better. We have a projected top speed of anywhere from 100 to 115 miles per hour at a 74% bank, and that's wide open throttle for 3 to 5 second bursts. So this is going to be something where we're testing not only the maneuverability of this newer design or this newer print, because what it is the same design. The only difference is I printed it much thinner than I did before, and then I reinforced the PET shell with epoxy. So that's kind of where we were going with lowering some of the weight on this. I was able to cut about half a pound or more off, and we are, because we are hauling that 6000 milliamp battery, so that's the whole reason behind that. So now what we're going to do, like I said, is oh, I've got to get this. I got a little tower I have to print to put this ELRS receiver on, or I'm going to put a top shell on here just over the top of this that I can take on and off. It'll hold that in the appropriate position. I'm not using GPS yet because I hate having to wait for it to find satellites to arm, especially if I'm just in my garage at this point test flying it. But once we get it out to the field, which will be after this, or that video where we do the flight inside and adjust the PID loops, I will hook up to GPS, and then we'll get that all set up so we can set waypoints and see how it acts with waypoints and automated flight. Again, this is a 70mm EDF Shrike version 10.1 clear. I love it with the PETG. It's got some lights on it too, so it's going to be beautiful. I think you've seen a couple of shorts where I actually showed off the lighting sequence, but if you haven't, hold on one moment and I will show you. And there it is. We got green flashing in the front, red flashing in the back. We have this beautiful blue that's encompassing the entire length of the drone with a white light that's kind of sweeps from back to front, so we kind of know our orientation while we're in the air pretty much the entire time we're flying, if you can't make out the green. So it's like that kind of is a dead giveaway. So it's going to help me because I'm slightly red deficient and green deficient, color blindness. It sucks, but at least doing it this way, I'll know. You know, if those lights are moving forward, then I know that where they end is the front of my drone. So that's going to be our color scheme while we're flying in the air. I think it's going to be beautiful. I think it's going to look good, and I think it's going to perform well because the first one certainly did. So stick around for that flight. That'll be the next video up. Like I said, PID loop. Make sure everything's great and stable, and set our arming modes, our horizon lock, angle modes, things like that, and then go out and take it to the field, probably at dusk. I think I'll take it out to the field at dusk. That'll give us a really good backdrop, and it'll give us some good color for these lights to come through while we're flying. I think it'll be a lot of fun, and I think it'll end up being beautiful. So motors will be coming in, and in that next video where we do the PID, we'll show the motor installation and how I do it with this, and then we'll start going through the PID loop and doing our hovers in the garage to make sure everything's stable before I sort of tack CA glue this top control plate down and you know, into place, because once I put it down, I don't want it to move. So next iteration, I'm going to put in actual points where I can screw this thing down, but when in doubt, CA glue, right? So all right, I'll see you all in the next one when we're taking her in the air. Thanks for watching. If you like what you see today, don't forget to subscribe, share it with some friends. I have other large drones that I'm working on. I'm sure you might find interesting. So thanks for watching all the way in if you made it, if you got this far, so it's very much appreciated. So I hope to see you all in the next one.